Hello, this is Greg Allison of Galactic Greg's coming to you on the 7th of April, 2021. Time on deck is 010200 hours Central Daylight Time. Yeah, in the wee hours. So Elon Musk has finally come out and tweeted and told us what happened with SN11, Starship SN11, why it went into a sudden rapid disassembly midair over the landing pad. So we're going to go into that. And in fact, I'll read you his tweet for starters. What he said is this. He said that ascent phase transition to horizontal and control during free fall, we're all good. That we know. A relatively small CH4, which is the methane, leak led to a fire in engine number 2 and fried part of the avionics, causing a hard start, attempting land and burn in the CH4 turbopump. He says, this is getting fixed 6 ways to Sunday. Okay, we're going to talk about potential fixes. We're going to talk about this a little bit. So that's what this video is all about, and we'll talk a little bit about, what they're planning to do going forward. So, small methane leak. Well, we saw the video. It made a fair little flame out there, and it probably was a small leak, but it did make a fair frame. But he said it fried the avionics. So I can see actually 2 or 3 problems in this whole scenario here, and in the course of their attempted landings, which not only they at least landed Starship 10, but then, well, it just didn't stay long. So, as I said before in my previous video, I said that, they need more quality control. So you need more quality engineering involved in, and of course, CM people, or quality management people, excuse me. You need more system safety and reliability. But system safety is what we're going to talk about now. I mentioned the quality control before. And, that might help check inspections, make sure things are assembled correctly, that all the materials are right, that all the part selections are correct. That's what quality control does. Are you getting the right grade parts? What's the pedigree? Yeah, maybe they don't want to do all that. That's what NASA does. But that way, you got good stuff. Did it get assembled correctly? Why are you having a leak? Is there some design problem? And why did that leak propagate to a failure of frying avionics? Well, that's kind of sort of perhaps easy to see, and the fire does kind of go up a little bit. So in system safety, we have a lot of standards. We have redundancy. People are aware of redundancy. We have design margin, where you build stuff thicker, heavier, so it don't break as easy. Like if you know what your operational load is, you put so much margin on it. Now, systems that are like transportation, like a gas bottle, that might be put on a truck, it might have a design margin of 2 or 3 times the yield of a material. I mean, 2 or 3 times what it would take to hold that pressure. Now, for redundancy, that's like having 2 or 3 strings, 2 or 3 entirely separate systems. That's not always required, but there's another little factor a lot of people aren't aware of, or they forget about, is separation of redundant critical systems. If one gets taken out, they don't all get taken out. Think about Apollo 13. When on the command module, they blew out a quarter panel. If all the critical systems went through that quarter panel, game over. Airlines require that redundant critical systems get radially separated. So do submarines. I know some rockets that are being built now that don't happen on. I don't know what the case is with a Starship. Just something from to bear in mind. Now, what probably failed here was the engine controller. The engine controller would be the avionics closest to the engine. It's just right there, usually where you're feeding in the propellants, so it can have the quickest reaction time. Well, okay, in engine controllers, you might have redundant channels right there in case you have failures within it, but an outside failure, common cause failure like a fire, would take out all channels in all likelihood. because they are right there. And it may be not practical to give you a separation of redundant systems if it's all sitting right there on the top of the engine, because you know you can't have the engine controller for this engine right here, and maybe well, you might, but it's probably not too practical to have the other one somewhere else in the spacecraft. In this case, what you have is engine out capability. Engine out capability is a very critical thing to have when you are taking off and landing a spacecraft. That goes way back to the old days. You know, I had my mentor when I first got involved in space work had been quite involved with that with the Saturn V rocket. You know, working the engine out capacities of each stage of the Saturn V vehicle. Now, the problem is that with a Starship, you know, when you're coming in for a quick landing, let me get my little Starship analog here. Oh yeah, I've got a Starship coming. Yeah, I'm gonna have a Starship real soon. A 3D printed model. In fact, I think I'm gonna have two, so I can illustrate my Venetian assembly technique. Let's just say this is a Starship. Okay, this little Nerf rocket. As we know, they went into the belly flop and they came down and had to stick a landing. Well, they had very little time to get it right. And if you had a problem with the engine, how much time do you have to sense that, correct it, and do an engine switch over and ignite another engine? None. Very little, very little. They are so tight in that margin. They're really essentially have no margin. You watch that thing come in, and they just do it like it, and it comes in hard and fast. So there's and they're always landing those things fast. Even when they're landing right, they're landing fast. Wow, that's very little margin. Sure, it saves on fuel, but you know, operationally, that may be just a little too aggressive, Elon. SpaceX, Miss Glenn Shotwell, that may be just a little too aggressive. There's another place to consider building in some margin. What that might buy you is better ability to switch engines and other things. Should you have some, as I understand, they're not trying to light all three engines. They only do a couple of engines when they come in. But you know, maybe that one you're shut off could be switched on, and it can land it. Now, I'm not absolutely sure what their protocol is for that, but definitely they need engine out capability and time to be able to switch at the last minute as they're coming in, and maybe make other corrections. So it would behoove them maybe to have a little design margin of reserve fuel so they could start that maneuver a little higher up. Not to me, maybe a little smoother too. And when you go full operational with a full-blown Starship and you got 100 passengers on it and you're flying missions that are not to Mars, but you know, point to point on Earth like they're talking about doing, and you're coming in like that, you know, 100 people are going to be losing their cookies all at once. And your passenger seats will be potty seats in a hurry. Whoo-wee. Yeah, that's going to be a scary last second maneuver, and it's going to have people's stomachs are going to be churning. So you need to be thinking about that. Think about the human factors. How are the people going to react when they're coming in? What about these guys coming back from the moon? Is that the way you're going to treat them on their first second back home? Of course, they'd be elated if they can just stick it, but you know, that's a scary maneuver if you're sitting in a spacecraft. You're falling to Earth pretty fast at that point. I mean, yeah, it's pretty smooth when they're coming and gliding, and it's falling fairly quick, but that's pretty smooth. When you switch over, she's coming down fast until the rocket motors take that velocity out. And you know, you want to bring that velocity to zero before you touch down, but they don't have a whole lot of margin to do that. Boom! I mean, they're just down fast. So what are we talking about here? We're talking about several principles within system safety. Design margin probably isn't the main thing you want in terms of your engine designs here, unless you've got some way to shield your engine controllers. You might do that. You know, you might put some thermal protection on the engine controllers themselves. That might be one of your 6 ways to Sunday's fixes. But a design margin might be, in this case, having operational margin of fuel. We only think of design margin as structure, but there may be some operational margin to think about there. Separation of redundant critical systems. This is something you can do. I don't know your architecture there, but and exactly what avionics fried. But if you got all the rest of your avionics that are close to the engines, you might want to rethink that one too. I'm going to move them up a little bit. Of course, I do understand that these are prototypes. This is not your actual fielded systems, and hopefully you will be a lot more diligent on safety when you start flying 100 passengers, from point A to point B on Earth. The FAA for commercial aviation, you're probably going to fall in the AST office instead. But for commercial aviation, you got to fly stuff millions of hours just about to get it flight certified. I don't think we're going to be doing that with rockets, or are we? So, you got to shake all this stuff out, and the redundancy and redundant separation of redundant critical systems is a very important principle. So I'm going to have to do, I'm still going to do my Rockets 101 class one day, and maybe a Rockets 102 or 3. And I'm going to be doing a system safety class one day on this channel. It might be just offered as a class. And I'll probably do avionic system safety and probably a lithium-ion battery system safety. I've written a lot of review item discrepancies against things on certain rockets due to not taking proper precautions with regards to the safety concerns that you need for flying lithium-ion batteries. Lithium-ion batteries are like little rocket motors. They have fuel and oxidizer all contained inside that little battery. So I'll talk about that in the future. But so suffice it to say, get you a better quality program, Elon. Get some system safety people involved. Hopefully some that are a little bit seasoned. Some that have also had experiences of breaking things in their life, knowing how things fail in real life instead of the models and the textbooks, and get some reliability people in your staff. I'm sure you got some of that. It might be time to kind of shake it up a little bit, bring in a few more. And maybe they don't all have to go to Boca Chica. I understand though that you're changing designs on the fly, so that's might be kind of hard if you're not right there to see what's going on. But if there's any stability in the design, it might work out. Now, where's SpaceX going? They're going to do the BN. Well, we got BN1. That's the booster, the super heavy booster. If this were a Starship, this is a Starship that we're used to. The whole thing is actually called Starship, but the super heavy is the booster on the bottom. In this case, this is an air pump cylinder, but for a nerve rocket. But it's kind of analogous, you know what I'm saying? Kind of works. So the funny thing is that the first one, of course, is a Pathfinder. They just used it to test out some things, and they actually cut it short just to get it through the high bay a couple of feet. But the design had already changed on what was going to be BN2 before they even got BN1 finished. And so so BN2 will likely have Raptor engines attached to it and be tested. It might even fly some hops like Star Hopper. Some are kind of mumbling about orbital. BN3 is thought that it might be an orbital vehicle, but all these things change, so you can't count on it. So, well, one thing to bear in mind, guys, is you're talking about putting 35 Raptor engines on your actual orbital BNs, boosters, super heavies. What are you gonna call it? You're talking about 35 Raptors. They're still having a lot of problems, these Raptors. 35 Raptors, and you're still having problems. Got to get your quality program set. You got to make sure that all those engines work every single time, always, without exception. Everything's got to be done exactly the same. Repeatability over and over and over and over again, many times over. It's got to be perfect, because you want all those engines to perform flawlessly and perform every time. You don't want fires with failure propagation. That's another FUBAR in system safety engineering, is failure propagation. We do things to ensure we don't have failure propagation as much as we can. So there you go. And by the way, I've been working 18 years in avionics systems, system safety. And I've also worked some of these other fields, done a little quality, done a little reliability. I've been involved in all these things across the spectrum of vehicles. So these are things I'm, familiar with. So that's what we need to do, or what you need to do, SpaceX. I'm sure you're looking at some of the stuff already. But just remember that as you're going 6 ways from Sunday, you might be down in the nuts and bolts, but back off and think about the big picture. You might be down there tweaking every little thing in the design. That might be your 6 ways to Sunday. But think about your process control. Think about, that's a dirty word to some people, but you got to have it exact every time. That's why ISO standards are so important, is they make sure that everything is built to precision every time. Of course, it could be built to precision and not be right. Just building, and make sure you got the right requirements and build to them too. But so there we have it. You can fix it. So where are they going? Like I said, BN3 might fly, might be orbital. So what they're planning to do is they're wanting to switch. So this SN 15 is a new design. So they got upgrades. We'll see how that works. And then their SN 20 and all are planned to be orbital. They plan to go orbital with SN 20 and all. But you got to get those engines fixed. No more leaks. No more leaks. You got to get your landings to stick. And we're going to try a whole new landing technique for the super heavy. And it's going to catch it. No landing legs. Coming down into a cradle. Like, mama. Well, let's hope it works. It's exciting what SpaceX is doing. Let me be blunt. It's exciting. I've sat there and picked on them a little bit, but it's constructive. It's with love. What they're doing is very exciting. If they can get the cost of launch down where they think, that's awesome. But to be able to fly people on it, especially point to point on Earth, you're going to have some very rigid standards to meet in terms of safety. So hope you the best. Wish you the best. Hope you get there. And with all that, I'm going to say, if you're not subscribed to my channel, please subscribe. Bang up that notification bell and click all so you can get more of my videos come up on this and other things. I'll be doing more of Venus habitats. And I got something to do on the moon with the Chinese and Russian space station. I got to work that up. And I got some great photography work done for the Venus stuff that's been worked up, some great architectural work, and a lot more concepts, a lot how to use spaceships as a strong back to start the construction. What? How you gonna do that? Stay tuned. That's why I'm banging the notification bell and click all after you subscribe, of course. So thank you for watching.